Don't forget to subscribe and ring that bell.
Why, hello, hello. We are going to do a request. I had a request after posting the 2023 free response questions. Someone made a comment with 1 weekend left before the AP exam. Can you put up the 2021, the 2019, and the 2015 free response questions? Well, the 2021 free response questions are already done. They'll be going up. So I am going to start the 2019 free response questions. Not sure if I'll get to the 2015 free response questions in a matter of 48 hours, but 2 of the 3 requests will go up. 2021 will be up tonight, and 2019 will be up before the end of the weekend, before Monday, before the exam is. So if I could do 2015, I will, but I love requests, and I got them. And because I appreciate all you guys, I'm going to work to get as much of this done as humanly possible to make you guys feel more confident and to put yourself in a position to be successful for this exam. Let's get going. By the way, we get a graphing calculator. Wink, wink. Let's roll. Problem 1 states, fish enter a lake at a rate modeled by the function e, given by e of t equals 20 plus 15 sine of pi times t over 6. Fish then leave the lake at a rate modeled by the function L, given by L of t equals 4 plus 2 raised to the 0.1 t squared. Both E and T and L of t are measured in fish per hour. And T is measured in hours since midnight. Midnight would represent T equals 0. The first statement, 1A, reads, how many fish entered the lake over the 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. Well, very, very basic. Basic. I'm going to go with green. I love green. My favorite color. Basic means if I have a rate, they're talking about fish entering. So I'm going to use function E. E is for entering. Fish enter the lake. This is a rate in fish per hour. Okay? So if I have fish per hour, man, I'll be okay, I swear. If I take the derivative of that, that's fish per hour, or hour squared. If I integrate that, I just have fish. Okay? Remember, this is a derivative. Going this way is a derivative. We are going backward. So we need to integrate. Integration always adds up. So integration will tell us how many fish. All right? So now that that's established, we just need to integrate from 0 to 5. I love how they even tell us from T0 to T5, even though up here they give it to us. All right? I've just got to integrate the number of fish or the rate at which the fish enter, which of E of t dt. This is showing work. You don't have to write the equation out every single time. The equation is given here. So if I say I'm integrating E of t, they're assuming that you're just integrating that equation, and that's what we're going to do. Because this is a calculator problem, let's roll. All right? Bam. Turn this. Let's turn this on. And in my calculator, in any TI-84 or TI-84 plus, we go to math and pick number 8. You can see right down here for 8, there's my little mousy mouse. It's n deriv. That. Right there. That means take the derivative. We are going to use, you know what? We're not going to take the derivative. I want to go to math 9. I'm going to integrate. Look at me go. Normally, it's normally question 3 or 4 I make that first little error. But from time 0 to time 5 a.m., we're going to integrate 20 plus 15 times the sine put a little fraction in there because I can, of pi x over 6. Going to close that parenthesis out. We need to make sure we have matching parentheses. There we go. You better make sure your calculator is in radian mode. Anytime we do calculators, see that flashing? Anytime we do trig in a calculator, should be radian. We're good. So let's hit enter. 153 points, I don't know, 457. Let's put this here out of the way. Boom. So that's approximately, oh my God, let's write it with an actual pen. I love the calligraphy pen in case you couldn't tell. 153.45. This 7 will go to an 8. Let's see if they tell us how they want the answer. Give your answer to the nearest whole number. Okay, if I got to round to the nearest whole number, that means my 4 will not round this up. That is just 153. You can put fish. It does not ask you for a label. And what I tell my students is, if they don't ask you for a label, don't worry about putting one. But because we're smart, I'm just going to leave the word fish there. Okay? Because I think if you put the wrong label, they could mark it incorrect. You can get a point off. So if they don't ask for a label, like I tell my students, I don't put one. I just try and put a label there when I can, just for the sake of knowledge, in case they were to ask you. 1A is done. 1B asks, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? And again, look how generous they are. They actually give us the bounds, okay? So the average number of fish leaving. This is telling me I need to use L of t, which is this right here. Okay, so average. Do I do change in y over change in x? No. They want me to average the number that leave per hour. The rate. They want me to find the average of the rate of fish leaving. Okay, this is the rate of fish leaving. In order to find that, to total up those numbers, then average that, okay, I want to find the average value of the rate of fish leaving, okay? So that tells me I need to integrate from 0 to 5, L of t, dt. This will give me the total number of fish that leave, but I got to multiply it times 1 over 5 minus 0. 1 over the difference in my bounds. Now, I have 2 students that every time we do something like this, they say, Visca, I don't like to say, well, I just like to divide by it like this. That is perfectly fine. That is perfectly fine. And every time a situation comes up like this, I always call out those 2 students. But you know what? Every time I call out those 2 students, they know the answer. They know what's coming, and they are very comfortable with it. I'm going to use the other way because in most textbooks, they do write it this way. But maybe some teachers do it differently. I don't know. But guess what? I really don't care because I get a calculator. And we're going to put this in the calculator, folks. Let's actually scroll this up so we can see my equation L of t as I'm typing it in. Clear this out. Now, I am going to say 1 over 5 minus 0 times math 9, not 8, 9, from 0 to 5 of LT, which is 4 plus 2 raised to the 0.1 x squared, because we don't have a t in the calculator. I mean, we do, but we use x, dx. 6.059. Approximately 6.059. It does not tell me to round. It does not ask for a label. The dishes are done, man. There we go. That's from Don't tell mom the babysitter's dead. It's an old movie and it's a classic movie. But hey, what are you going to do? We're done with 1B. Okay, 1C. It reads, at what time t, for t between 0 and 8 inclusive, is the greatest number of fish in the lake? Justify your answer. I love these types of problems, especially with the calculator. So let me explain what we're going to do before we actually do it. All right? The way I like to do this problem is the following. To find the greatest number of fish here, the greatest number, as long as the number of fish that are entering the lake, we're adding more, is higher or is always greater than the number of fish. Let me do this in green. Green for good, right? As long as the number of fish entering is always more than the number of fish leaving, my quantity will keep growing, okay? The moment more fish are leaving than entering, well, then I'm losing fish. Okay. So I want to see where these things are equal. I want to see the number of fish entering higher up on the graph or showing more. Let's do this on the graph to show you. And because we get the colored graph, I'm going to use green and red because, well, I can. All right, here we go. So I'm going to clear this out. I'm going to go to y equals. For green, well, for red, I'll put the leaving, right? Right where the y is y2, it's the red. It's 4 plus 2 raised to 0.1 x squared. All right, and I'm going to use green for entering. Okay, that is 20 plus 15 sine. All right. Create a fraction here, and that is pi x over 6. Pop out. Now, my window, I only want my x-axis. It tells me down here between 0 and 8. Okay, between 0 and 8. 0, 8. I'm not sure how high up on the y-axis I'm going to go. Let's start at 0 and go to 100 by 10s. Okay, I mean, you could do zoom fit and change your window. This is what I'm going to go with. Okay, here are the fish leaving this red graph. Okay, you can see it's not that real high on the graph until the end, because at the end, a lot of fish leave. These here, the green one, that is the fish that are entering in. Okay, and this is what I'm talking about. I love this. I love this. All right? And on your test, maybe we sketch this. Okay, let's do if this was a real test. 8, half of 8 is 4, half of 4 is 2. We got 1, 3, half of between 4 and 8 is 6. So we got 5, 7. All right, and red. L of t kind of starts like this, kind of creeps up, does something like this. This is L of t. E of t, let's see, 1, 2, 3, 4, 5, 6. This is where 6, so it's a little bit after 6. Probably right here it's going to intersect. Kind of starts up, kind of comes up like this. It does something like that. We want to figure out where this point is on the x-axis, our time. How come? Because if we follow our graphs, the fish entering, it's higher up on the graph than the fish leaving. As long as the entering fish, let's label this E of t. As long as E of t is higher, that means more fish are entering. So all this time, there are way more fish that are coming into the lake than are leaving. Okay, boom, boom, boom. So I'm getting higher and higher quantities. They're going to be the same right here. Then after that, notice there's way more fish leaving than are coming in. So we're actually losing fish because more fish are leaving. So up until this point, I always have a surplus, way more fish coming in. So at this point is when I have my greatest amount, because after that, I start losing fish. More fish are leaving. So on our calculator, we just need to find that intersection point. I hit second trace, and I pick intersect. and hit enter 3 times. 1, 2, 3. There it is. At the bottom, it says x equals 6.203. I'll round that 3 up to a 4. So I got 6.204. That's the time where I'm going to have the most fish. So it tells me that I need to what? Justify, delete. And I could write this one of a million different ways. So I'm just going to say at time equals 6.204. That's the most. How come? Because until this time, okay, fish entering the lake, which is E of t, is greater than fish leaving, which is L of t. That's it. And again, you could write, because the function E of t is greater than the function L of t. You can say because E of t minus L of t is 0 right there, with E of t being above L of t. There are several different ways. This is just one of them. 1D states, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. First of all, let's take a step back and read that again. Is the rate of change, that means the derivative of something, right? But they gave us rates. E of t and L of t are already rates. So is the rate of change in the number of fish increasing or decreasing? We should automatically recognize that increasing and decreasing is a derivative right there. So what are we taking the derivative of? The rates they gave us. So the derivative of, or in this case, we can think of it as the rate of the rate they gave us. So I don't want to find E of 5 and L of 5. I want to find E prime of 5. And I want to find L prime of 5, okay? And what I want to do is I want to find the difference between them, okay? How come? If L of 5, L prime of 5 is bigger, then, well, actually, what I should say is I want to combine them. And if I have a positive or negative number, that's what I'm looking at, okay? So we will subtract the difference in the number of the rate entering and the rates of the rates leaving. Are we going to get a positive or negative number? And we have the calculator to do this, okay? So we don't have to write everything down on the paper. All we got to do is find, now we can go to math 8. If you were here when I did part A, part B, I almost went to math, well, I did go to math 8, but I needed to go to math 9. I almost made a derivative of an integral I needed. I caught it, but we finally get to use math 8. Let's start with E of t. I'm going to take the derivative of 20 plus 15 sine, create a little fraction here because I can, of pi times x over 6, close out that parenthesis, at the point where x is 5. All right, we have a negative value. Now let's do the same thing, math 8, but of L of t. So let's find the derivative of L of t. 4 plus 2 raised to the 0.1 x squared at the point where x is 5. Booyah! I want to find the difference of E of t, which is this first one, minus, well, I should say E prime of 5, minus L prime of 5. That's negative 10.723. We'll round up. 10.723. negative. Guess what? Since that's negative, it's decreasing. Okay? So I'm going to state this, right? It's decreasing. It's decreasing. Now, I love how it doesn't say in the context or whatever. Just explain your reasoning. Decreasing since E prime of 5 minus L prime of 5 is less than 0. Done. Problem 1 was cake. And God, I can't say this enough. I love cake. I'll eat vanilla cake if it's chocolate frosting. I love chocolate. I love chocolate frosting, but I love chocolate cake even more. I don't even need frosting. Eat that with no fork, bare hands and all. All right, we are done. I'll see you for problem 2.
Don't forget to subscribe and ring that bell.